Today, we're going to dive into a hidden, incredibly precise step that happens deep inside a factory. A step that pretty much determines whether the device in your pocket lives a long, healthy life or dies a really early death. Think about it. You use stuff with lithium-ion batteries all day, every day. Your phone, your laptop, you name it. But these things don't just roll off an assembly line ready to go. They start out as, well, basically lifeless, inert objects. So what's the secret sauce that wakes them up? The whole transformation from just a dormant collection of metals and chemicals into this vibrant source of energy, it all hinges on one single, incredibly precise moment in its creation. It's a moment of activation, of awakening. And that moment, it's called electrolyte filling. This is when a special liquid gets injected into the totally dry battery cell, which finally allows ions to start moving and electricity to start flowing. It's so fundamental to its existence that engineers have this great name for it. They call it the cell's first breath. But before that first breath can be taken, the stage has to be set perfectly. This isn't just a simple injection. Oh no. It is a meticulously controlled procedure, and it all starts with the environment itself. Think of it like a hospital's sterile nursery. This whole thing has to happen in what's called a dry room, an atmosphere with almost zero moisture. Why? Because moisture is the absolute enemy. It can literally poison the battery's chemistry before it even gets a chance to live. And if that wasn't enough, the electrolyte liquid itself is often warmed up just before it goes in. So why the heat? Well, it's all about making the electrolyte flow better. Warming it up makes it way less viscous. Think less like cold honey and more like warm water. This is crucial because it helps the liquid seep deep into the battery's incredibly complex, porous internal structures through something called capillary action. Okay, so with the nursery all prepped and ready, it is time for the main event, injecting that electrolyte. This is the lifeblood that's going to awaken the cell and unlock all its electrochemical potential. It's basically this high-tech four-step dance. First, the dry battery cell is placed into a chamber. Then, a deep vacuum is pulled to suck out every last molecule of air. After that, the electrolyte is precisely injected. And finally, the pressure is cycled up and down to make absolutely sure that liquid saturates everything inside. Now, there are a couple of main ways to do this. The first is vacuum filling. It's pretty straightforward. You create a vacuum, suck all the air out before you even introduce the liquid. The other method, pressure cycling, kind of works the other way around. You inject the liquid first, then use these alternating pulses of high pressure and vacuum to physically squeeze it into every little pore, forcing any trapped air out. The techniques are different, but the goal is exactly the same: perfect saturation with zero trapped air bubbles. So you would think, after all that high-tech injecting, the job is done, right? Well, not quite. In fact, the next phase is defined by a total lack of action. It's this period of just patient waiting, and it's absolutely critical for the battery to mature. Yup, you heard that right. After all that sophisticated pressure and vacuum control, the battery just sits. This is called the soaking period. It gives those natural capillary forces the time they need to finish the job, slowly and thoroughly, drawing that electrolyte into every single microscopic nook and cranny of the electrodes. And I know what you're thinking. Why wait? Can't we just speed this part up? Well, let me tell you, rushing this quiet, passive step has serious, and I mean serious, consequences. Because if you rush the soaking, you get what's called incomplete wetting. And that creates the #1 villain in battery manufacturing. The dreaded dry spot. These are these tiny little regions inside the battery that the electrolyte just never managed to reach. And these dry spots are so bad because they basically act like roadblocks for electricity. They create these pockets of high resistance, so the current has to awkwardly flow around them, which creates unevenness, localized hotspots, and ultimately a battery that degrades incredibly fast and is just prone to failure. This is why preventing these microscopic flaws is such a massive focus. So you're probably getting the picture here. This whole process has to be absolutely perfect. There are no do-overs. And that brings us to quality control and the obsession with precision. I mean, just look at the kind of parameters they're constantly monitoring. The vacuum level has to be deep and stable. The injection rate has to be slow and totally controlled to prevent splashing. The temperature can't really waver by more than a couple of degrees Celsius. And then there's the weight check. This is just mind-blowing to me.
The final weight of the electrolyte that's inside that cell has to be within 1% of the target. 1%. That's it. Any more or any less points to a huge defect, like a leak or some kind of structural problem. The wiggle room is practically zero.
And this really brings it all home. This quote from our source material says it all. Any mistake, any tiny bubble, any dry spot that's created during this one step is permanent. It's locked into the battery's DNA forever. You can't go back, you can't fix it.
Okay, so we've been geeking out about vacuums and viscosity deep inside a factory. But why does any of this microscopic, invisible precision matter to you and the phone in your hand?
It's everything. It is literally the difference between a high-quality battery that reliably holds a charge and gets you through your day and a cheap, low-quality one that just fades way too fast and dies right when you need it most. That first breath truly determines its entire lifespan. So the next time you pick up your phone, just think about that first perfect breath it took in some ultra-dry, sterile room somewhere. It really makes you wonder, doesn't it? What other invisible, hyper-precise manufacturing marvels are quietly powering the world all around us?